Okay, let's wrap up this baby with the final section on future research questions and challenges. Despite the large volume of research on WDs, a number of important questions remain about their behavior and impacts, either because they have not yet been investigated or because studies have arrived at divergent results. We conclude this review by summarizing these important unknowns based on the discussions throughout this paper. For each entry, the relevant section or subsection is given in square brackets. So even though I have been brief on each section so far, this gives us a way to revisit them and grasp the most salient points along with the remaining open questions, right? What is the sensitivity of WD tracks and their statistics to the choice of reanalysis? Of course, this could be explored by comparing different reanalysis, and that's a fairly straightforward task. Do WDs occur in clusters arriving in rapid serial succession with longer gaps between the groups? So it's like a wave packet or so. If so, why? This behavior has been found in extratropical cyclones as well over the North Atlantic. Such work would need to overcome the limitations of tracking algorithms where WDs in rapid succession may not be easily separable, degrading the quality of detection. So it comes to detection and tracking and improving that part. Can WDs merge and split like cyclones tend to do? It's certainly possible given the behavior of similar PV streamers and cutoffs, as well as the discussion in Cannon et al. How would such events affect associated precipitation? As in the previous question, this work would need to overcome the limitations of current tracking algorithm, or maybe there is a way of going back to the fundamentals of PV streamers and cutoffs and see if that has a certain frequency and duration and life cycle, and how many of them actually end up being recognized as WDs, right? There must be something fundamental going on at the PV level. What is the relationship, in terms of baroclinic instability and streamers and cutoffs? I have not gone into the details of that here, but I have discussed that, a little bit of that, in the tropical dynamics course that you can follow up on. If I find a good paper specifically on PV streamers and cutoffs, maybe I will make a podcast and add it as a supplemental to this one. What is the relationship between the different regions of WD cyclogenesis and their downstream behavior and impacts? Do those forming away from the subtropical jet have inherently different characteristics? Are there different WD cyclogenesis mechanisms beyond simply dynamical baroclinic instability? So cyclogenesis in the WD context is different than the extratropical or tropical cyclones in terms of the processes that feed back, where the moisture becomes available, where the positive feedbacks pick up, and this idea of having ascent ahead of it and descent behind it, and so on. So it's a different system, even though it has many similarities, as we said before. Do conditional instability of the second kind CISC, heating rate proportional to relative vorticity, or wave CISC, heating rate proportional to vertical velocity, relative vorticity and vertical velocity, instabilities? So do conditional instability of the second kind or wave CISC instabilities play a role in the PV convection relationship as WDs intensify near the Himalayan orography? This could be complementary to the baroclinic instability mechanism proposed by Baudouin et al. I have seen some work where people look at it as waves, and then the energy that waves deposit, wave, I think it's called a wave energy flux or so. Is it that it's coming along and hits the orography and then begins to deposit energy, in which case maybe it is packets of WDs that come together and reach some certain threshold at which you get these strong events in terms of precipitation and other things. Why fronts, for example? Why do some WDs contain frontal regions while others do not? This is one of the major characteristics separating WDs from extratropical cyclones, which almost invariably contain frontal structures. So extratropical cyclones have more frontal structures than WDs. Such analysis would benefit from front-centered composites for example, using gradients in equivalent potential temperature, which has not yet been carried out for WDs. So we looked at the vertical structure, but what equivalent potential temperature means we have discussed elsewhere, and you can follow up on that. Related to the previous question, some case studies have identified that bands of very high vorticity can develop near the surface during the passage of WDs, stretching from the Sulaiman range in central Pakistan to Himalaya. What causes these bands and what are their impacts? So it's not being specifically mentioned here, but orography must have something to do with this entire interaction on the eastern end of the WDs from wherever they originate, North Atlantic, Mediterranean, and so on. Related to the previous question, some case studies have identified that bands of very high vorticity can develop near the surface during the passage of WDs, stretching, again I'm rereading it for whatever reason, Alzheimer's, stretching from the Sulaiman range in central Pakistan to the Himalaya. What causes these bands and what are their impacts? A rigorous quantification of the moisture sources of WD precipitation has not yet been performed. Some kind of a dynamic recycling model application may work. Even though it is known that the majority comes from the neighboring Arabian Sea, what fractions are carried over longer distances from the Mediterranean, Black or Caspian seas? Do different source ratios affect the resulting precipitation? How sensitive are these ratios to WD characteristics such as latitude? Such research could build on comprehensive case studies by Boschi and Lucarine, sorry, I don't know how it's pronounced, but also the precipitation along the way is better done in a dynamic recycling model. I'm mentioning this, but there are moisture source calculations from for the monsoon region, for example, which can give you an idea. So if a WD rains more over Pakistan or Iran, does it bring less rain to the Himalayan regions and the land region over India, or are they unrelated? WDs vary considerably in their intensity and impacts. What's the best way of classifying or categorizing them? Should we place a classification on WD impacts such as precipitation, characteristics such as latitude, or dynamics such as upper level vorticity or wind speed? Are there differences between WDs that arise as PV cutoff lows and those that arise as dynamical instabilities in the subtropical jet? Okay, there is a difference which is discussed a little bit in the variability section 2.6, which I didn't go into, but you can follow up. So PV cutoff lows and those that arise as dynamical instabilities in the jet itself. Zonal jets have intrinsic instabilities, baroclinic instabilities. They begin to wobble and then shed off these eddies, and PV cutoffs are slightly different. What are the primary causes of intraseasonal variability in WD frequency and other characteristics? This is very tricky because there is an intrinsic intraseasonal variability in the region and it's actually global, but what is specific to WD frequency and why does it also seem to pick intraseasonal variability? Is it related to the monsoon circulation? But that's only a summer phenomenon. But the northeast monsoon also has intraseasonal variability, but the WD process is very far away from the northeast circulation. Neil et al. Showed that weather regimes associated with WDs also lead to increased winter precipitation over northeast India. It's not known whether this is caused by WDs propagating into the region, instability caused by the position of the jet, or some other weather phenomenon. Right? I mentioned northeast monsoon, but we don't know exactly how these things work. How can better knowledge of WDs translate to decisions around water management? This is a multidisciplinary topic which also requires better observations, operational predictions, forecast skill assessment, and decision support tools. And as of now, we said the forecasts are predictions are not good at any time scale. What are the socioeconomic losses associated with historic WD activity? How are these best quantified? What kind of WD characteristics are associated with socioeconomic losses? So are all WDs the same? Are some somehow causing more impacts than others? And how can we separate them, etc.? or what are the processes behind them and what are the differences between them, which WD characteristics such as location, intensity and timing is associated with natural hazard occurrence most sensitive to. So it's likely that this will be different for different hazards. So different WDs causing different hazards, or same WD behaving differently in different contexts. We don't know. Cold waves have thus far only been anecdotally linked to WDs. Is there a climatological link between the two? If so, which is more important? Northerly advection of cold air in the rear flank or sustained heavy cloud cover? So we don't know that, right? Mid-latitude connections or something local like cloud cover. Cold waves have thus far, okay. What role do WDs play in driving nor'westers, storms that impact the northeast India and Bangladesh? If any. So nor'westers, you have nor'easters off the coast of US that are very popular, that just spin up and can dump a lot of snow or rain, and we have nor'westers that impact northeast India and Bangladesh. And understanding this link would be crucial to reducing lightning related mortalities in this region. And lightning is a serious hazard over India, not just associated with WDs, but also during the monsoon in the peninsular India, for example, state of Maharashtra, and so on. Do WDs occurring during the summer monsoon have different characteristics than typical winter WDs? Monsoonal WDs have access to an abundant moisture supply that is not present in the winter months, but does this significantly affect their structure and or evolution? There is also evidence that WDs occurring during the summer arise from high latitude PV cutoff lows rather than arising as instabilities within the subtropical jet. So we looked at the interaction of the Indian monsoon and WDs, where we raised some of these issues. Is the seasonality of WDs changing as Valdia suggests? So those are, seasonality of WDs as you keep warming the background and you create all these shifts in the jet, like there is some ideas that the subtropical jet is shifting northward, or is that decadal variability? All these are critical questions. More work is needed to establish the link, if any, between WD characteristics and slowly varying teleconnections. Many of these have been investigated in detail in previous studies, but connections with the MJO, SAM, PDO and IOD are still not well understood. These would in turn improve seasonal forecasts. Well, everything is connected to everything. So separating contributions from intraseasonal timescale MJOs to interannual and decadal timescales is going to be very tricky, because you don't know what the feedbacks are between them anyways. The Pamir bifurcation occurs when the subtropical jet passes near the Pamir mountains. These mountains act like a wedge, deflecting WDs south into India and north into Central Asia with only small variation in jet latitude. How can the impact of Pamir bifurcation could be reduced in forecast? If there is a critical subtropical jet latitude at which forecast uncertainty increases, is there a critical subtropical jet latitude at which forecast uncertainty increases significantly? Okay, so subtropical jets are unstable anyway, but when it hits the Pamir mountains, slight shift to the north or south can completely change its further trajectory, and that can affect the forecast very much, obviously. Are there upstream signals that says latitudinal position is favorable for one or the other path in terms of the bifurcation? It would be beneficial to conduct quantitative analysis on the quality of IMD warning bulletins so that stakeholders know at what lead times and in which locations they are most reliable. So just assess the usefulness and usability already being generated in the warnings. More quantitative research is also needed on extended range and seasonal WD forecasting. This includes but is not limited to quantification of track frequency and intensity errors also can still be improved through hybrid statistical techniques that leverage connections to large-scale forcing such as the NAO and ENSO. Note that AIML has not been mentioned here. Maybe the data is not enough, or maybe in this review article they haven't caught any AIML articles on WDs. I haven't seen any either, and these are the experts, so I'm sure if they exist they would know about it. Aside from better understanding of teleconnections, how might sub-seasonal and seasonal predictions of WD activity be improved? Studies of Western Himalayan paleoclimate over the last 10 millennia often disagree considerably on periods of surplus or deficient wind precipitation and hence WD activity. To what extent is this due to contamination from the summer monsoon signal, and to what extent can it be explained by the large spatial variability in the climatic trends of the Himalayan precipitation? So, uniformitarian principle would say the contributions of WDs has remained similar. So you take winter precipitation reconstructions and try to infer WD activities, but maybe that's not so solid in terms of the correlations or the level of contribution from WDs to winter precipitation. What is the relationship between observed elevation dependent warming and change in WD behavior? So that's for instrumental and reanalysis records. What role do aerosols play in the moist thermodynamics of WDs? Are regions or months of high aerosol optical depth associated with increased WD precipitation? How have observed trends in different aerosol species affected WD activity? I would say this is kind of a second order effect, because if we don't get a very good handle on the basic dynamics, then inferring aerosol impacts is going to be even more complicated, especially in terms of cause and effect, right? If precipitation washes out aerosols, is there a buildup of aerosols prior to the WD precipitation that affects the WD precipitation as it evolves? What are the respective roles of interdecadal variability and climate change in recent observations of seasonal and regional trends in WD frequency? So there are intrinsic decadal, multi-decadal time scales which have to be separated from trends and global warming impacts, but it's also tricky because climate change itself will modulate the multi-decadal variability. 20-year cycle may become 30-year cycle, and we might think that's trend, but there may still be a multi-decadal variability. Gets very complicated. Without good models or good data, it's hard to separate them, but we are stuck with it in this sense. Reanalysis will hopefully keep getting better and give us some new information there. What are the respective roles of interdecadal variability and climate change in recent observations of seasonal and regional trends in WD frequency? As we saw that this is not well resolved, but then we really have to separate those as well. Did I repeat that? Maybe I did, but doesn't matter. What is the impact of climate change on WD intensity and why? So we talk about rapid intensification in cyclone business because there is energy being built up in oceans, and they are moving slower, which is not explained very well yet. But if they are moving slower and more energy is available, is that a cause for rapid intensification? I've discussed that in the cyclone podcast series, but here this is not exactly a cyclone or an extratropical cyclone, but if it is intensifying more or slowing down or intensifying less, then how is this related to warming? Finally, coming closer to the end, what role have WDs played in supporting or destroying the Karakoram anomaly in the last century? How is this likely to change over the coming century? So if Karakoram anomaly is basically because it's not, glaciers are not retreating or depleting as fast as the others, maybe it's even growing, as we mentioned before. And is this a temporary phenomenon? Is it some kind of a local refugia for snowfall that's protecting Karakoram, or is this going to flip over and will Karakoram also begin to go the way of the others? Only 2 studies have investigated in detail how WD behavior will change in future scenarios, and they are in disagreement. More refined studies looking at a broad range of WD characteristics are needed to resolve this. I am not a big fan of projecting so far into the future, as I already said. So in my mind, the decadal into decadal predictions will be much better in terms of spending resources and advancing our understandings. Which has the greater impact on trends in the winter precipitation over the western Himalaya and surrounding region? Changes to thermodynamics or changes to atmospheric circulation? Thermodynamics is basically, you can think of it as moisture dynamics, warming, moisture, convection, clouds, etc. Circulation is what we refer to as dynamics, so those are obviously related to each other, but you can think of it as circulation anomalies versus humidity and humidity anomalies versus circulation. There is also only a weak consensus on the projected future decreases of winter precipitation in the western Himalaya. Studies leveraging high-resolution models that are capable of resolving orographic feedbacks are needed to make more robust estimates of these changes both in the near and far future. So near future would be a couple of decades, far future is 2080 to 2100 and so on. But most likely if the changes are related to global circulation changes or global teleconnections, then will regional high resolution studies help? Well, you need global high resolution studies, and they are coming along. So maybe we will get some new results in WDs and winter precipitation in the future. Okay, so that's a nice summary of the paper actually, and it's helpful to have looked at all the others, even though I've been brief, and this provides a context for all that discussion as well. So I'm going to conclude this paper here, the summary of this paper. It's a long paper. My summary is not that long, but still I hope it's enough to give you a sense of what is known, what are the new recent insight, and what remains largely unknown and has to be followed up on. What are the various questions that are of importance, especially because you want to improve enough understanding to make better forecasts. Okay, let's leave this here.